So, outliers. It's funny, I catch myself spelling it wrong sometimes with an A instead of an E. For whatever. So, Freudian, I think. So, how do you define? How to, and I'm going to put the word numerically. Numerically. Define them. Mine, go with your idea. I like your idea over there. Let me hear it again.
Well, it's just the distance between the two. The most extreme and then what's next to him could be like the standard deviation or the deviation between the two.
I love it. How about distance between the most extreme point? How about if can I paraphrase a little bit?
Yeah.
How about the most extreme point, and I can even put points. You can have more than one extreme point.
Right.
Distance between the most extreme points and typical.
Sounds like range to me.
It does, doesn't it? Yeah. Comparative ranges? Sounds like that to me too, actually. But the problem is now I've created another word, typical. Now, how do you think typical and outlier are related?
Well, the average.
Good. You guys are microanalyzing. Thank you for that. How are they related to each other? The word typical and the word outlier are what? Most probably. They're probably complementary. They're far away from each other. Good. I like what you guys are giving me how to measure. Just in general, if a data point is typical, it's probably not an outlier. Yeah. And if it's an outlier, it's not typical. So essentially, numerically define an outlier. I'm going to Englishly define it as atypical data. It's atypical data, I think, is a pretty good way of defining it. Now, of course, that's a very political way of defining it. It's atypical, yes. Giving you no measurement as to what actually is typical. I threw a stat of the day blog up today. I try to keep that every week or so. The 5 worst states and the 5 best states to go to school in for K-12 education. Okay, Oregon didn't make the top 5 or the bottom 5. So Oregon's out of the, what would that be, the 90th percentile and 10th percentile, I guess. But I threw up a question on the stat blog. How did they measure these things they were measuring? They measure things like performance on standardized tests. Should you even look at that to see if a school is working? I don't know. It's an open question. I personally don't think so. I think standardized tests suck. But that's why do we use them?
They're a unit of measurement. I mean, something.
It's a poor measurement, but yes, it is a unit. It's easy to measure.
Right.
You can easily say you got that right, that wrong, that wrong, that right, and put it in a percentile and go without ever looking at what you're actually measuring. It's been shown fairly conclusively that they're racially biased against certain minority groups. So when you tell me Louisiana is a terrible state because of standardized testing, I go, there might be a given reason for that based on how you're measuring it.
And when you say that, I'm just curious, is that on purpose or is that just like how they wrote the test?
That's thin ice I don't want to tread on, if you don't mind.
Sure.
Because it's easy to say yes, but it's also easy to say it's on purpose, not because of nefarious behaviors, right, but because
ignorance. Who's
the race that creates the test?
Yeah.
It might not be the races that are then being discriminated against because we take too much for granted. Yeah, I think
makes sense.
I think it does. When you start thinking about it, you're like, wow, you create what is comfortable to you in most cases. And sometimes that has more than just you bias. It might have a racial or an ethnic bias. I mean, so I don't have a good answer for it. Like, it's just that there's been evidence that shows those kinds of things. Good question, good question. But anyway, the point is this whole, I've taught it atypical. Now, you guys have given me some good measures. Any other ideas? Any other ideas? So, the big takeaway is that it's atypical somehow. But we're not exactly sure how to measure that. I like the distance idea. I like that very much. I like the use of standard deviation. So I heard a couple people say standard deviation. Got to be careful with that, right? Standard deviation implies you got to have some kind of symmetric data. So let's try to generate some symmetric data right now. Right now. Here's what I want you guys to do. Oh, Carla, go, please.
Oh, I was just going to say, is it anything that lies outside of the interquartile range plus 50%?
Good! We hinted at it last time, didn't we? Good! And that's a nice fallback if we don't have, if we don't have what? If we don't have bell-shaped data, that's a nice fallback. Because that'll work every time, right? Percentile ranking? Yeah. That works regardless of shape. Thank you. Here's the deal. I've seen probably half a dozen different ways to calculate what an outlier is. I want to focus on just 2 with you guys. The 2 that show up in research. The one Carly just talked about, which is a very, very nice one that works for all data sets. and one that works specifically for bell-shaped data sets. So what I want to try to do today is I want to try to generate two different sets of data. I think I can do this too, based on past results. Here's the first one. Estimate my height to the nearest inch. Estimate my height to the nearest inch. If you need to stand up to get a look, that's fine too, but don't compare myself to, you can't do no comparisons.
Counting the hair?
No counting, no, well, I don't know. Hang on, take the hair down. Yeah, knock the hair down. Estimate my height to the nearest inch.
6'2".
All right, get some estimates. Good, good. Get some estimates.
6'2".
If history is a guide, this feels weird. If history is a guide, this should be bell-shaped when we collect our data up. If history is a guide, we'll see. We'll see. If not, we'll try something else. Is this freaking people out as far as guessing? I'm an outlier. You got it? To the nearest inch. Everybody got one? Got my heights? Okay, good. Let's shut this down for a sec, and then